Before we wrap up this fabric material, I like to add two more things to make it a bit more interesting. One of them is displacement. Now, we've touched upon this in the beginning of this course when I told you that height could mean different things. In the broader sense, the height map is just that grayscale image we've been building for most of the episodes, and that feeds into the normal node. So what we see on our model right now is not the height, but just the normal map. But when it comes to displaying the height itself, what we actually mean by that is displacement. Now, displacement is a heavy process because it relies on subdivision of the geometry, so for that reason I usually turn it off unless I really need it. And materials like fabric are mostly flat anyway, so I knew we wouldn't need it until we reached the very end. Now let me show you what our displacement looks like if we turn it back on. And remember, right now it's taking in the raw height map that we built here. Okay, so material, default, edit, and height. Designer actually went back to its default display settings with a little bit of displacement. You can see it if we look at it at very low angles. We have this sort of bumpiness on the edge here. And to see it better, we need to crank up the tessellation. Otherwise, designer will not have enough geometry to displace. That's one very common mistake that beginners do often when they try to increase the displacement and nothing happens. That's because they forgot to tessellate the mesh. So let's type in a large number like 50 and push the scale to 10. Okay, there are a few things that I'd like to show you here. First, you see that we get this sort of spikes here around the edges. That's due to the tessellation. See if I move the slider. Now you might be thinking, okay, then we just need to increase the tessellation until it's all nice and smooth. But the thing is, you will end up with a crazy geometry that will make everything extremely slow without fixing all the artifacts. So it's not the smartest way around this. And I'd like to draw your attention to another problem. See, if I look at the weave, well, it appears that even the threads are getting displaced, which is way too much. The only thing that is worth displacing here are the trim and the gemstones. These are the bits that should really stick out. The rest can remain flat and rely on normal information only. It means that to get a good displacement map, we need to create it separately. And we can do that easily by just reusing different bits from our graph. Okay, since we only want to displace the trim and ornaments, I'm going to take a dot and start from this mask here. Everything else is black, meaning flat, which is exactly what we want. One other way we can avoid these spikes and artifacts that I mentioned and that you often get when you use displacement is by simply blurring a little the input to avoid hard edges. Let's take a blur and set it to 0.2, just to have a bit of slope here. Okay, that's already much better. The only problem is that it makes everything a little blobby and the gemstones in particular don't stand out enough. You can try to find your own solution to this. What I'm going to do is simply lower this with a level, then do a blend, and add the gemstones mask on top. Like that. Okay. Now you might argue that even though it's a little bit better, we still have jagged outlines and artifacts, and this is due to the resolution. If we check how it looks in 4K, well, all of a sudden everything becomes nice and sharp, so it's a balance to find between details and efficiency. In any case, we now have a good displacement map. Alright, the second property I wanted to mention is translucency. Right now, the gemstones look like they are made out of plastic or some sort of opaque material, which is not exactly the look I was after. And translucency looks like the answer to this problem. But if I go to the base material maps, you see that we don't have any translucency slots. And so I wanted to walk you through this situation where you work in a template that is made for certain maps, but then you realize that you need something more that is not in the template. In our case, translucency. Now, the good news is that it's not really a problem, because Designer lets you play with as many channels as you wish, no matter what template you chose in the beginning. And you see that if I were to take any node, right-click and drag it into the viewport, I would get to choose between all these different channels, including channels that I don't have in my base material, like emissive, coating, anisotropy, and so on. Now, the thing is, I don't want to just display a new channel in the 3D view. I want it to be a part of my material, something that will be packed and exported with it at the end. So the way we can do it is very simple. You see, we have all these final outputs after our base material, the color, the normal, the roughness, and so on. And all we have to do is to create just one more output. So let's type in output. Here we go. And now we're going to replicate that structure we see on the other outputs. So identifier, label, group, and usage. Okay, so identifier, let's call it translucency. Same for label. Group, it's important that we place it under the material umbrella, just like the rest. And finally, usage. This is going to tell designer how to use that information we're going to plug in there. So here, all we have to do is to scroll down until we find translucency here. And that's it. Now, of course, we need to plug something in there. Translucency maps work a little like metallic maps. They are basically masks that tell the shader what is translucent and what is not. So in our case, since we only want the gemstones to be translucent, it's going to be very easy. Just take a dot, grab the gemstone mask, and connect it to your output. And that's it. Translucency usually needs a bit more information to work properly, like the absorption color and distance, but I'd rather deal with that directly in the final rendering app than create maps just for this in Designer. It's up to you, but I just find it a bit more flexible. And with that said, we can finally call this material done. However, like I said in the introduction, what makes parametric materials special is that they are not a static collection of maps, but a dynamic system that you can interact with even after closing Designer. So in the next video, we will see how we can expose some of these parameters to the final user so that he doesn't end up with just the current green fabric, but also with the power to change it however he likes.